Okay, example 2, parallel lines. Write the equation of the line that is parallel to each line. So this is really, really baby food stuff. This is easy peasy lemon squeezy. So here's the equation of the first line, 3x plus 1. Notice I know that it's this line because the b value is 1. It's crossing the y-axis at 1. So this line up here, since it's parallel, is going to have the exact same slope, isn't it? So its slope is going to be equal to 3, because this slope is 3. Does that make sense? They're parallel. So this slope has got to be 3 too. But its b value is going to be different. Its b value, in this case, is not 1, but 4. So the equation of this new line is going to be y equals 3x plus 4. So I gave you the equation of the first one, and I expected you to figure out which one it was, and then you worked out the next one. So, this one, the slope is negative 3 over 4. And look, they're falling down from left to right, so that makes sense. That means that as my run, I go 4 to the right, I go down 3 from each point. Okay, and this one is supposed to be plus 9. So my b value for this one is 9. So this must be this line. Do you agree? Because it's crossing at 0, 9. So that's got to be that line. So the line that they want me to calculate the equation for is this one. That's the line they want me to come up with the equation for. Well, since the lines are parallel, the slope for both of them, so if I use m1, m sub 1 that says, so the slope of the first one is going to equal the slope of the second one. So my slope is going to have to be negative 3 over 4. Now my y value, my b value of the second one is 7. That's where it's crossing. So the equation is just going to be negative 3 over 4x plus 7. Nothing to it. Easy peasy. Now if you wanted to, you could calculate the slope using those points. You could count over. You could do the formula. But what a waste of time when I know that those lines are parallel. Example 3. Determining which equation is steeper. For each pair of equations, determine the equation that is steeper. Provide an explanation. Well, the explanation is pretty easy. This one has a slope of 2. This one has a slope of 5. The steeper one is this one. And the reason why it's steeper is for every 1 unit in the run, we go up 5 units. For this one, we go up 5 units. And how much do you go up in this one for every unit over? You only go up 2 for that one, compared to only 2 units. Is that easier to read now? Talking to my studio audience. Is that any better? Okay. And does that make sense? That this one's going to be steeper because think of it, it's rise over run. So this is 5 over 1. So every 1 I go over, I go up 5. Where this one, for every 1 I go over, I only go up 2. So this is definitely going to be the steeper line. I'm just waiting for the studio audience to copy this down. Those of you at home can fast forward a little bit. Okay, so I'm going to flip. So we do the same thing again. What a waste of paper, waste of space. So which one of these is going to be steeper? I'm going to ask my studio audience. First one or second one, which one's steeper? Fernando? First one, you're absolutely right. Now, this is a negative slope, so it's going over and down, but that doesn't get into the steepness argument. Nobody cares about that. Look at this. This has a slope of negative 3 over 1. This has a slope of 1 over 1. So when I move over 1, this one is going to be steeper because for every 1 unit of run, we drop 3 units compared to increasing by 1 unit. So this one, for every unit that you go over, you go up 1. But this one, for every unit I go over, I go down 3. I could do a little sketch of this, and maybe that would make some sense. I'm going to zoom out a bit. I'm going to use some of this space I got down here that I certainly don't need. Here's our Cartesian plane. So here's an example of a point, of a line. I'm just going to start here. And if I go over 1 and up 1, over 1 and up 1, that would be a slope of 1. Now that's not this line because that's negative 1. That b value is negative 1. I really should have moved that down to here. Notice it's parallel. See how I did that? I know the slopes are parallel, so I just moved the line down. So this is actually a better representation of this line because it has the right b value now, and it has a slope of 1. So this line here, this one has a b value of 2, so 1, so 2, but it has a slope of over 1 down 3. So I'm going to go over 1 down 3, and it's going to look something like this. Over 1, down, over 1, down 1, down 2, down 3. I'll put it here out of the way. It's going to look something like this. Over 1, down 3. And as you can tell, this line is steeper than this line. Think of it as a ski slope. If you were going down a ski slope, someone on this slope on skis, not bad, we're okay. But someone on this one on skis, that's a little dangerous. I'm thinking that's a black diamond, right? Okay, so you can always use that analogy. Okay, the last one. So we've got 2 slopes here. This slope is negative 8 over 1. This slope is 8 over 1. So a bit of a trick question. Which one's steeper? Curtis?
I think the second.
How come?
Because the second number is increased by 1.
This number.
Yes.
That has nothing to do with steepness. Absolutely nothing. That has everything to do with where it crosses the y-axis. So, yeah, that's not going to do anything for steepness. Do you want to try again?
They're the exact same.
They are. Neither is steeper. Why? Because they're both over 1. Now, one goes up 8, and the other one goes down 8. But in terms of steepness, they're exactly the same. Both go, I can't spell. Both go either up or down 8 units for each run unit. So if I go over 1 in the run, that just doesn't look right. There you go. So if I go over 1 run unit, I either go up 8 or I go down 8. Either way, that steepness is the same. I either go up 8 or I go down 8. The steepness remains the same. Okay, guys, you got some homework from your textbook. It should be fairly straightforward. Get going on that, and we'll be back in a moment.